Okay, so this video is about the binomial distribution. So as of right now, the Lakers are about to start the Western Conference Finals, and I have been watching some of those games. Um, so I thought, why not talk about LeBron James today? So let's say So I looked up his free throw percentage, and his career-wide free throw percent is 73.5%. Let's calculate the probability that he makes anywhere between 0 and 10 of his next 10 free throws. Let's note that this is a binomial distribution because we have 10 trials, each with 2 possible outcomes. He either makes or he misses, and with 1 success probability. So we want to fill out this table to begin with. So let's just write some things down to begin with. The first is n. So n is the number of trials here, and we have 10. P is the success probability, which is 0.735. And then Q, which is the probability of failure, which is 1 minus P, which would be 1 minus 0.735, which is equal to 0.265. Again, if you want to double check that, just do equals 1 minus 0.735, and you get 0.265. Okay, so we want to calculate the probability that he makes 0 free throws. We want the probability he makes 1, all the way up to the probability he makes all 10. So we're going to use the function binom.dist k n p false. Okay, so let's do this. So let's do equals binom.dist. Okay, so what's k here? Well, k in this case is 0, so I'm just going to click 0, comma, n is 10, so I'm going to write 10, comma, p, well, p is 0.735, comma, space, and we're going to write false, and parenthesis, enter. And then we're just going to go ahead and drag this down. And we have our probability for each of these. So notice that the only thing that's changing up in these formula bars, so if you look up here, the only thing that's changing is the C column. So all we're doing is changing the K value, because the number of trials does not change and the probability of success doesn't change. So we can go ahead and drag this formula so that only this number is the one that's changing in this formula bar. So again, up here, that's just the C value. So what's the probability that he makes all 10 free throws? Well, we already calculated that probability, and it's right here. So I'm just going to, in this cell, write equals. I'm just going to calculate the probability he makes all 10, which is right here, 0.046. So I'm going to click that cell, enter. What's the probability he makes at least 6? So at least 6, that would include 6, 7, 8, 9, and 10. So I could just sum up all of this probability. So I'm going to say equals sum, open parenthesis, and I'm going to highlight all of the numbers I want to add up. Close parenthesis, enter. So that was equal to some data. And if you had, I already have these cells formatted, but let's say like here I had done equal 0.04. So all I did was like, I'm clicking on this cell, coming up here, I'm going to center it, and then I'm coming over here to clicking percent, and then I'm going to use these buttons to increase the number of decimal places so that I get 2. So that's how I'm doing all of that. So what's the probability he makes fewer than 6? So fewer than 6 would be 0, 1, 2, 3, 4, and 5. So we need to add up all of these probabilities. So I'm just going to sum that up. So I'm going to say equals sum, open parenthesis, and then I'm just going to sum up 0, 1, 2, 3, 4, and 5. Close parenthesis, enter. So 9.69%. What's the expected number of free throws? Okay, so let's recall that in a binomial distribution, the expected value is just the number of trials times the probability of success. So let's just write, I'm going to write expected value of x. So this is just going to be equals to n, so 10 times the probability of success, so times 0.735. So the expected number of free throws he makes is 7.35. Again, P came from up here, 0.735. What's the standard deviation? So remember, the variance of a binomial is n times p times q. And then the standard deviation is the square root of the variance. So let's start with the variance. So variance of x. So it's going to be equal to equals n is 10 times p, so 0.735, times q, which we found to be 0.265. So 0.265, enter. But we wanted the standard deviation, which is the square root, so I'm going to say equals SQRT, open parenthesis, click on the variance, close the parenthesis, enter. And I get 1.4. Okay, and then what assumptions do we need to make in order for the binomial distribution to be valid? And that's just that we need independent and identically distributed trials. So what does independent mean? It just means whether he makes that first free throw does not affect the chance that he makes the next free throw and so on. And identically distributed just means that there are still only two outcomes. It's either make or miss. And there's just one success probability throughout all of the trials. It's always going to be 0.735.